Look at these two circuits carefully. Can you tell the difference between them? In circuit A, the bulbs are connected in a series. In circuit B, the bulbs are connected in parallel. Let's see how both circuits behave. The bulbs in circuit A are dimmer than the bulbs in circuit B. If a bulb is removed from each circuit, then the remaining two bulbs in circuit A stop glowing, but in circuit B they continue to glow. Can you explain why this should happen? The filament of the bulb is a resistor. Resistors are electrical devices that resist the flow of electric current. So, circuit A is an example of resistors connected in series, and circuit B is an example of resistors connected in parallel. Based on your observation of the bulb's behavior, can you explain how resistors connected in series differ from resistors connected in parallel? To understand the flow of current through these two resistors better, let us connect a voltmeter and an ammeter. Let us take the values of R1, R2 and R3 as 2, 4 and 6 ohms respectively. The potential difference across the first resistor will be V1. Similarly, the potential difference across the other resistors will be V2 and V3. The potential difference across the three resistors is equal to the sum of the potential difference across the individual resistors. By Ohm's law, V1 equals IR1, V2 equals IR2, V3 equals IR3. I is the amount of current and R is the resistance. How will you calculate the total resistance for this circuit? The total resistance of this circuit, IR, equals IR1 plus IR2 plus IR3. If the current flowing I is kept constant, then R equals R1 plus R2 plus R3. Thus, in a series connection, the total resistance and the total current flowing through the circuit are both distributed among the resistors attached. Also, if one resistor is removed or damaged, then it will cut off the flow of current. Let us do an activity. Consider a torch bulb whose resistance is 15 ohm and a resistor of 5 ohms. Both are connected to a 5-volt battery in a simple connection. Calculate the total resistance of this circuit, the current that passes through it, and the potential difference across the bulb and the resistor. First, we will calculate the total resistance in the circuit. The bulb's resistance is 15 ohm and the conductor's is 5 ohm. So, the total resistance is 20 ohms. The potential difference between the two terminals of the battery is 5 volts. By applying Ohm's law, we can calculate the current I flowing through the circuit. It will be 0.25 ampere. Now, by applying Ohm's law, we can calculate the potential difference across the bulb as 3.75 volts. And the potential difference across the resistor is 1.25 volt. If we calculate the total resistance in this circuit by applying the formula R equals V divided by I, we get the total resistance as 20 ohms. This 20 ohms is also the sum of the resistance of the bulb and the conductor. Let us now understand the arrangement of resistors connected in parallel. Let us take the values of the three resistors R1, R2 and R3 as 2, 4 and 6 ohms respectively. We have I equals V divided by R. By applying Ohm's law, we get these three equations for I1, I2 and I3. From this we can derive this equation also. Let us do an activity. Here, the three resistors R1, R2 and R3 are of 7 ohm, 14 ohm and 28 ohms respectively. They are connected to a battery of 10 volts. By using Ohm's law, we can calculate the current flowing through the first resistor. By applying the formula I1 equals V divided by R1, we get the amount of current passing through R1 as 1.4 ampere. Similarly, we can calculate the current passing through R2 is 0.7 ampere. Similarly, the current passing through R3 is 0.3 ampere. So, the total current in the circuit is 2.4 ampere. And the total resistance is 4 ohms. Note that the total resistance is lesser than the individual resistance because the resistors are connected in parallel.